Welcome back to Engineering Inebriated, and today we're going to talk about keto enol tautomerism. So this is a complicated concept in organic chemistry, but essentially the definition of it is the equilibrium between the keto and enol. And the keto and enol are versions of a molecule. So keto is referring to a ketone or aldehyde. For example, acetone would be the keto. And then an enol is an alkene with an OH functional group. Here's the enol version of that keto. So there's two ways to create this equilibrium between the two, where the acetone is turning into its enol molecule version. One is through base-catalyzed method. So here we have the base coming over and taking the hydrogen off of that carbon, which is then a carbanion, and those electrons from the carbon go up, push the electrons up onto the oxygen, which causes the oxygen to be negatively charged, but that also stops the carbon from being charged, which is generally unfavorable in organic chemistry. Then the electrons from that oxygen go off and attack the hydrogen on the water, and bam, you have your enol with the catalyst restored. Now the other method of coming about this is through the acid-catalyzed method. So first you have the electrons on the oxygen actually attacking a hydrogen on a hydronium ion. From there you have the charged oxygen, which now is an alcohol essentially, and the water molecule's oxygen attacking the hydrogen on the carbon, which goes off onto the water molecule, recreating the hydronium. And the electrons from that carbon will go up and push that oxygen, push the double bond onto the oxygen, which will get rid of the charge, recreate the catalyst, and create the enol form.